Assalamu alaikum wa rahmatullah wa barakatuh. I will return with you, or I return to a new video by discussing chapter 5, which talks about discrete probability distribution. Here from the syllabus I will we will discuss section 5.1, 5.2, 5.3. 5.4 we will omit it. 5.7 we will omit it since there is no time, and we will discuss also 5.5, 5.6. Here we will begin with a definition of a random variable. Random variable here, a random variable which has some abbreviation RV. Random variable will be defined as RV. We define the concept of an experiment and its associated experimental outcomes. A random variable provides a mean for describing experimental outcomes using numerical values. Random variables must assume numerical values. Here, a random variable is a numerical description of the outcome of an experiment. These definitions it is only for understanding, not for memorizing. In fact, a random variable associates a numerical value with each possible experimental outcome. The particular numerical value of the random variable depends on the outcome of the experiment. A random variable can be classified either discrete or continuous, depending on the numerical value it is assumed. Here we have random variable, discrete, random variable, or continuous. Random variable. Discrete random variable. Here we have discrete random variable like 0, x equal 0, 1, 2, and so on. Here x equal 0, 1, 2, 3, and so on. But here x between -1 and 1, or x between 0 and 1, and so on. You cannot count it. Continuous, you cannot count it, but discrete, you can count these data. Here we have an experiment of discrete random variables. Discrete random variables like this. Experiment, contact 5 customers. Random variable number of customers who place an order, which is 0, 1, 2, 3, 4, 5. Inspect a shipment of 50 radios. Number of defective radios from 0 till 50. Operate a restaurant. Rent for 1 day. Number of customers 0, 1, 2, 3, and so on. Sell an automobile. Gender of the customer, maybe a male, buy this car, and we put 0, or female, we put 1. Another kind, continuous random variable. A random variable that may assume any numerical value in an interval or collection of intervals is called continuous random variable. Since there is an interval and you cannot calculate it, like what? Time, weight, distance, temperature, and so on. Here in the example, operate a bank. Time between customer arrivals in minutes, x greater than or equal to 0. fill a soft drink can max 12.1 ounces, number of ounces, x greater than or equal to 0, less than or equal to 12.1. Construct a new library. A percentage of project complete after 6 months, x between 0 and 100. Test a new chemical process temperature when the desired reaction takes place. Minimum 150 Fahrenheit, maximum 212 Fahrenheit. X between 150 and 212. Notes and comments. One way to determine whether a random variable is discrete or continuous is to think of the values of the random variable as points on a line segment. Who choose 2 points representing values of random variables if the entire line segment between the 2 points also represent possible values for the random variable. Then the random variable is continuous. I will not give you any homework, and also I will not solve any question. Number 2, developing discrete probability distributions. The probability distribution for a random variable describe how probabilities are distributed over the values of the random variable. For a discrete random variable x, a probability function denoted by f of x provides the probability for each value of the random variable. Here we will have probability like this. Here, probability distribution for number obtained on one roll of a die. We know everyone that a die is equally likely. Outcomes of a die are equally likely. Then we have 6 faces. Then the probability of each face will be 1 over 6. Probability distribution for the number of automobiles sold during a day to DiCarlo Motors. We have it. This is given in the question. And the most important thing, this box, required conditions for discrete probability function. F of x greater than or equal to 0. The probability is always greater than or equal to 0, less than 1, and summation of fx equal 1. F of x greater than or equal to 0, less than or equal to 1. And we have to give the name f of x as a distribution, probability distribution. Here f of x, the probability of x, the probability distribution of x is given in table 5.3. Here, I discuss it here. Probability denoted by f of x provide the probability for each value of a random variable. This is a symbol. In order to say they are probability distribution, you must check the 2 values, the 2 conditions. And this graph is not with us. Here, discrete uniform probability distribution. You can know it, not very important. F of x equal 1 over n in the total number of values of the random variable may assume. And here, I will not solve with you, but we can solve one. Yani we can solve number 7 here. Is this probability distribution valid? we must check all these values greater than 0, less than 1. Number 2, the addition of it. How much? 0, 1, 3, 4, 4, and 6, 0. Yes, 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 since it satisfies here 5, no, not 5.3, it satisfies 5.1 and 5.2. 5.1 and 5.2. What is the probability that x equal 30? Probability x equal 30 will be 0.25 this. What is the probability that x is less than or equal to 25? Probability x less than or equal to 25 means the probability of x equal 25 plus probability x equal 20, which is 0.35. This is B, and this is C, and this is A. What is the probability that x greater than 30? D. Probability x greater than 30 means that the probability x equal 35, which is 0.4. I solve it quickly with you in order to see or understand the probability distribution for discrete, and I will not give you a homework. Here, section, expected value and variance. The expected value, which is the mean or mean of a random variable, is a measure of central location for the random variable. We have taken it in section 3.1, chapter 3. The formula for the expected value of a discrete random variable is x mu equals summation xi fi, which is, this is a probability distribution. Probability distribution, both denotation x mu are used to denote the expected value of a random variable. Equation 5.4 shows that to compute the expected value of a discrete random variable, we must multiply each value of a random variable by corresponding probability f of x and then add the resulting products. Variance, التباين. The expected value provides a measure of central tendency for a random variable, but we often also want a measure of variability or dispersion. Section 3.2. Just as we use the variance in chapter 3 to summarize the variability in data, we now use variance to summarize the variability in the values of random variables. The formula for the variance of a discrete random variable follows as this. Variance of a discrete random variable, var sigma square summation x minus mu whole square multiplied by f of x, where mu is the mean or expected value. 5.5, this equation shows an initial part of the variance formula is the deviation of x minus mu, which measures how far a particular value of the random variable is from the expected value, or mu. In computing the variance of a random variable, the deviations are squared and then weighted by the corresponding value of probability function. the sum of these weighted squares deviations for all values of the random variable is referred to as variance, and the notation var x or sigma square are both used to denote the variance of a random variable. You notice that sigma square between 0 and infinity and standard deviation between 0 and infinity, but mu between negative infinity and positive infinity. For the calculation, the variance for probability distribution of the number of automobiles sold during a day in Descartes motor is summarized in table something. We see that the variance is 1.25. The standard deviation defined as the positive square root of the variance. Thus, the standard deviation take the square root. I will show you how to calculate it when we calculate the sample standard deviation or sample variance. Here it is a population. This is population variance, and this population standard deviation. Population standard deviation. For the homework or solved examples, I will not give you any homework, and I will not solve any question about this section with you, but the most important section will be here. This is omit. Omitted this section. Here I will see the most important here, very important section, and also the other section is very important. Binomial probability distribution. Binomial probability distribution is a discrete probability distribution that has many applications. It's very important. It is associated with a multiple step experiment that we call binomial experiment. Binomial experiment exhibit the following 4 properties. Properties of a binomial experiment. first of all, the experiment consists of a sequence of n independent trials. Second, two outcomes are possible in each trial: fail, and success. Success and failure. The probability of success donated by B doesn't change from trial to trial. يعني probability of success B doesn't change from trial to trial. It is fixed. And probability of failure 1 minus B doesn't change from trial to trial. The trials are independent. Then the four important properties: the trials are independent, the trial consists of sequence of n identical trials, the outcomes are two, success and failure, probability of success B, probability of failure 1 minus B, and doesn't change from trial to trial. If properties 2, 3, and 4 are present, we say that trials generated by a Bernoulli. What is the meaning of Bernoulli? Suppose we toss a coin and you have two outcomes, head and tail. One time you toss it. This is Bernoulli. After that, if you try this experiment many times, more than one, it will be binomial. It will be what? Binomial trial. And in a binomial experiment is or our interest is in the number of successes occurring in trials. In trial, Bernoulli one trial. After that, if you make a second, third, and so on, it will be binomial experiment. Let X donated the number of successes occurring in n trials. We see that X can assume the values 0, 1, 2, 3 up to n. 0, 1, 2, 3 up to n. Because the number of values is finite, X is discrete. You can count it. Discrete random variable. The probability distribution associated with this section random variable is called binomial probability distribution. Binomial probability distribution. Here, the experiment consists, suppose the experiment consists of 5 identical trials. Each trial involves tossing of one coin. 2 outcomes are possible, which is a head or tail, and consider one is a head, success, and tail is a failure. The probability of a head and probability of a tail will be 0.5 and 1 minus B 0.5. The trials or tosses are independent because the outcome on any one trial is not affected by what happened on other trial. Here we notice that here Martin clothing store problem, I will delete it. Also I will delete it. Here it is important. Here it is important. The number of experiment outcomes resulting in exactly X successes in n trials can be computed using the following formula. Here you have n from X, which is combination, we know it. N factorial n multiplied by n minus 1, n minus 2, and n minus 3 multiplied till 2 by 1, and 0 factorial will be 1. Here, if you return back to here. 5.10, where is 5.10? Here. Return back to 5.10, which is a combination. Because of equation 5.1 shows the number of outcomes in a binomial experiment with x successes, equation number 5.11 gives the probability for each sequence involving x successes. We combine equation 5.10 and 5.11 to obtain binomial probability function. We will have this, the last one, binomial probability. This function is f of x equal n over x, b to the power x1 minus b to the power n minus x, where x, the number of successes, b, the probability of success on one trial, n number of trials, f of x, probability of x successes in n trials, and n over x. Can you open it like combination? For the binomial probability distribution x, x is a discrete random variable with x equal 0, 1, 2, up to n. 0 otherwise غير ذلك. 0 otherwise غير ذلك. Probability function f of x applicable for values x equals 0 up to n. Martin clothes can be omitted here, and this I don't need it. Using tables here, I don't need the tables, and I don't need to complete the last answer here. This is important. Expected value and variance for binomial distribution. Here in section 5.3, we provide formulas for computing the expected value and variance of a discrete random variable. After certain calculation, we will have to summarize these two equations. Expected value and variance, e of x n by b, variance n b for 1 minus b, and sigma will be square root n b for 1 minus b. Then you must memorize this. Here I don't want it. This example. Here at the end of this section, notes and comments. The binomial table, I don't need it. Shows, but I don't need it. Here, some sources present the binomial table. Here, you will notice this idea. F of 2 means, since it is, in using such a table, one must subtract entities in the table to find probability exactly. For a discrete, since binomial distribution and Poisson distribution are discrete, at the point you must here probability x less than or equal to 2 means probability x equal to 0, probability x equal to 1, probability x equal to 2. This is why in order to find probability at 2, I must cancel probability x equal 1 and probability x equal 0. The binomial table, this is not, this is the meaning I need it. Here, homework, page 248, number 31. 32, 33, 33, 34, 35, 34, 35, here 36, no, I don't need it, 37, 37, 38, 37 and 38, 37, 38, 39, leave it, 40, 40, 41, 42, and 43, 40, 40, till 43, 40, 40, 41, 42, 43. Next time, since the video is going to be too long, next time or next video I will solve with you 1 or 2 questions from this section binomial, and I will move to the last section in chapter 5, which is Poisson probability distribution. Thank you for your listening.